Welcome back, guys, to the second part of our lecture. Before we were doing balancing chemical reactions, now we're going to be looking at it using what's known as the polyatomic ions. This is going to simplify the entire process a lot more, and you're going to be able to do it in a very quick fashion. So let's look at what I mean. Before, when I was analyzing these elements, I had it listed as lead, sodium, separate nitrogen, and then separate hydrogen, and lastly oxygen. We're no longer going to do that. I'm going to look at nitrate as a unit, NO3, and I'm going to look at hydroxide as a complete and whole unit. So let me show you what I mean. When we first take stock of what we have, we're still going to say, how many leads do I have on the right? I have 1. How many leads do I have on the left? If I look over here, I can see that I have 1. How many sodiums do I have on the right? I have 1 sodium on the right. How many sodiums do I have on the left? Just 1. Now, here's where it becomes a little different. You have to ask yourself, how many nitrates, how many NO3s do I have on the left, for example? When you look on the left side, you'll see NO3 in parentheses, and you see a subscript of 2 on the outside. What that 2 signifies is that you have 2 whole complete units of nitrate. So over here, I'm going to list this as having 2 complete nitrates. How many nitrates do I have on the right side? Well, there's no parentheses here, so you can imagine that there's an invisible parentheses 1 on the outside. So that would mean that I have 1 whole unit of nitrate on the right side. What about hydroxide? Well, on the left side, again, I don't see any parentheses, so I know that there's an invisible 1 on the outside. What about on the right side? Here, it does have a subscript, has a subscript of 2 on the outside. So that means that I have 2 hydroxides on the right side. Now I just need to balance this. I start from the element on top and I work my way down. This one's already balanced. Sodium's already balanced currently. Nitrate, I have 2 on the left, but only 1 on the right. So what coefficient can I put over here that when I multiply it times my invisible 1 will give me a total of 2? Well, it'd have to be 2 times 1 to give me 2 nitrates. So now this is already balanced. I have 2 nitrates on the left, 2 on the right. Key thing to remember is that as soon as you apply your coefficient, you have to distribute it to both the sodium and the nitrate. So this actually changes the number of sodiums that I have on the right side. That's not a problem. I'll change it here. And now work my way back up. I have 2 sodiums on the right. I only have 1 on the left. So what do I have to do? Put a 2 here. And now I have to remember to distribute that 2 to the sodium and to the hydroxide. So 2 times the invisible 1 of sodium gives me 2 sodiums, and that's balanced. And then 2 times my invisible subscript of 1 on the outside of hydroxide also gives me 2. And suddenly, this chemical reaction is already balanced. I have 1 on both sides here for lead, 2 sodiums, 2 nitrates, and 2 hydroxides. I'm completely balanced. I make sure to put a 1 on the blank ones. And then if they're asking for it, I add all the coefficients together to get the sum. It'd be 2, 3, 4, 6. And that's it. I think you'll agree. This method is much quicker, but you can only do it when you have the exact same hydroxide on both sides. So for example, if I had NO3 on the right, but I had NO2 on the left, you cannot use this method. You would have to break them up into individual elements. But when they're both present in the exact same form, that's when you can go ahead and use this method. Okay? Thank you.